Good morning, students. Today we are going to see the next lesson area. We know that if the sides of closed polygon are given in the units centimeter, meter, kilometer, then their areas are in the units square centimeter, square meter, and square kilometer respectively, because the area is measured by squares. We know some formulas. That is, first, area of square is equal to side square, area of triangle is equal to rectangle is equal to length into breadth. Third, area of right angle triangle is equal to 1 upon 2 into product of sides making a right angle. And fourth, area of triangle is equal to 1 upon 2 into base into height. Let us see some new formulas. That is, area of parallelogram. One activity is given here. Draw a big enough parallelogram ABCD on a paper as shown in the figure. Draw perpendicular AE on side BC. Cut the right angled triangle AEB. Join it with remaining part of the rectangle ABCD as shown in the figure. Now, note that the new figure form is a rectangle. The rectangle is formed from the parallelogram, so area of both the figures are equal. Base of the parallelogram is one side, that is length of the rectangle, and height is the other side, that is breadth of the rectangle. Therefore, area of parallelogram is equal to base into height. Remember that if we consider one side of the parallel sides of a parallelogram as a base, then the distance between these parallel sides is the height of the parallelogram corresponding to the base. A rectangle ABCD is a parallelogram. Segment DP perpendicular to side BC, segment AR perpendicular to side BC. If side BC is a base, then height is equal to length AR is equal to length DP is equal to H. If segment CQ perpendicular to side AB, and if we consider segment AB as a base, then corresponding height is length QC is equal to K. Therefore, area of rectangle ABCD is equal to length BC into H is equal to length AB into K. Some solved examples. First, if the base of the parallelogram is 8 cm and height is 5 cm, then find its area. Area of a parallelogram is equal to base into height. 8 into 5 is equal to 40. Therefore, area of parallelogram is equal to 40 square centimeter. Second, if area of parallelogram is 112 square centimeter and base of it is 10 centimeter, then find its height. Area of parallelogram is equal to base into height. Therefore, 112 is equal to 10 into height. 112 upon 10 is equal to height. That is, therefore, the height of the parallelogram is 11.2 centimeter. The practice set 15.1, based on this formula, we can solve in your notebook. Now next, area of rhombus. Draw a rhombus as shown in the adjacent figure. We know that diagonal of a rhombus are perpendicular bisectors of each other. Let length AC is equal to D1 and length BD is equal to D2. Rectangle ABCD is a rhombus. Its diagonal intersect in the point P. So we get 4 congruent right angled triangles. Sides of each right angled triangle, area 1 upon 2 length AC and 1 upon 2 length BD. Areas of all these 4 triangles are equal. Length AP is equal to length PC is equal to 1 upon 2 length AC is equal to D1 upon 2, and length BP is equal to length PD is equal to 1 upon 2 length BD is equal to D2 upon 2. Therefore, area of rhombus ABCD is equal to 4 into area of triangle APB is equal to 4 into 1 upon 2 into length AP into length BP is equal to 2 into d1 upon 2 into d2 upon 2 is equal to 1 upon 2 into d1 into d2. Therefore, area of rhombus is equal to 1 upon 2 into product of lengths of diagonal. Some solved examples based on this formula. First, length of the diagonal of rhombus are 11.2 centimeter and 7.5 centimeter respectively. Find the area of rhombus. Area of rhombus is equal to 1 upon 2 into product of length of diagonals. Here, two diagonals are given. Therefore, put the values of diagonal is equal to 1 upon 2 into 11.2 upon 1 into 7.5 upon 1. If we can solve it, we get 42 square centimeter is the area of the rhombus. Next example, area of a rhombus is 96 square centimeter. One of the diagonal is 12 centimeter. Find the length of its sides. Let rectangle ABCD be a rhombus. Diagonal BD is of length 12 centimeter. Area of the rhombus is 96 square centimeter. So, first find the length of the diagonal AC. Therefore, area of a rhombus is equal to 1 upon 2 into product of lengths of diagonals. Therefore, 96 is equal to 1 upon 2 into 12 into length AC is equal to 6 into length AC. Therefore, length AC is equal to 16 centimeter. Let E be the point of intersection of diagonal of a rhombus. Diagonals are perpendicular bisectors of each other. Therefore, in triangle ADE, measure of angle E is equal to 90 degree. Length DE is equal to 1 upon 2. Length DB is equal to 1 upon 2 into 12 is equal to 6. Length AE is equal to 1 upon 2 into length AC is equal to 1 upon 2 into 16 is equal to 8. Using Pythagoras theorem, we get length AD square is equal to length AE square plus length DE square is equal to 8 square plus 6 square is equal to 64 plus 36 is equal to 100. Therefore, length AD is equal to 10 centimeter. Therefore, the side of rhombus is 10. The practice set 15.2 is based on this formula. We can solve it in your notebook. The next, area of trapezium. Draw a trapezium ABCD on the paper such that segment AB parallel to segment DC. Draw segment AP perpendicular to segment DC and segment BQ perpendicular to side DC. Let length AP is equal to length BQ is equal to H. Height of the trapezium is the distance between the parallel sides. After drawing the perpendicular in rectangle ABCD, its area is divided into three parts. Out of these, triangle APD and triangle BQC are a right angle triangle. Rectangle ABQP is a rectangle. Point P and Q are on segment DC. Area of trapezium ABCD is equal to area of triangle APD plus area of rectangle ABQP plus area of triangle BQC is equal to 1 upon 2 into length DP into H plus length PQ into H plus 1 upon 2 into length QC into H is equal to H into 1 upon 2 length DP plus length PQ plus 1 upon 2 length QC is equal to 1 upon 2 into H into length DP into plus 2 length PQ plus length QC. If we solve this, we get the area of rectangle ABCD is equal to 1 upon 2 sum of the lengths of parallel sides into H. Therefore, the formula is Area of trapezium is equal to 1 upon 2 into sum of the lengths of parallel sides into height. Some solved example based on this topic, that is, in the trapezium, if distance between the parallel sides is 6 centimeter and the length of the parallel sides are 7 centimeter and 8 centimeter respectively, then find the area of the trapezium. Distance between parallel sides is equal to height of the trapezium is equal to 6 centimeter. Area of trapezium is equal to 1 upon 2 into sum of the sides parallel, length of the parallel sides into height is equal to 1 upon 2 into 7 plus 8 into 6 is equal to 45 square centimeter. Practice set 15.3 is based on this formula. We can solve it in your notebook. Next one, area of triangle. We know that the area of triangle is equal to 1 upon 2 base into height. Now we will see how to find the area of triangle if height is not given but lengths of the three sides of a triangles are given. Let A, B, C be the lengths of the side BC, AC and AB respectively of triangle ABC. Let us find the semi-perimeter of the triangle. Semi-perimeter is equal to S is equal to 1 upon 2 into A plus B plus C. Area of triangle is equal to square root of S into S minus A into S minus B into S minus C. This is the formula known as Hero's formula. Example number 2. Some solved examples on this formula. If the sides of a triangles are 17 centimeter, 25 centimeter, 26 centimeter, find the area of triangle. Here A is equal to 17, B is equal to 25, C is equal to 26. Semi-perimeter S is equal to A plus B plus C upon 2. 17 plus 25 plus 26 upon 2 is equal to 68 upon 2 is equal to 34. Then area of triangle is equal to square root of S into S minus A into S minus B into S minus C. If we put the values and solve it, we get 204 square centimeter. The next example, the figure of a plot and its measures are given. Length LM is equal to 60 meter, length MN is equal to 60 meter, length LN is equal to 96 meter, length OP is equal to 70 meter. Find the area of the plot. In the figure, we get two triangles, triangle LMN and triangle LNO. We know the lengths of all the sides of triangle LMN by using Hero's formula. We will find the area of the triangle in triangle LNO. Side LN is the base and length OP is the height. We will find the area of triangle LNO. Semi-perimeter of triangle LMN is equal to S is equal to 16 plus 60 plus 96 upon 2 is equal to 216 upon 2 is equal to 108 meter. Therefore, area of triangle LMN is equal to square root of 108 into 108 minus 16 into 108 minus 16 into 108 minus 96. If we solve it, we get 1728 square meter. And triangle area of triangle LNO is equal to 1 upon 2 into base into height is equal to 1 upon 2 into 96 into 70 is equal to 96 into 35 is equal to 3360 square meter. Now area of rectangle LMNO is equal to area of triangle LMN plus area of triangle LNO is equal to 1728 plus 3360 is equal to 5088 square meter. Area of the plot LMNO is 5088 square meter. Now we know some formulas, that is area of parallelogram base into height, Second, area of rhombus 1 upon 2 into product of lengths of diagonal. Third, area of trapezium is equal to 1 upon 2 into sum of the lengths of parallel sides into height. And next, if the sides of triangle ABC are given ABC, then Heroine's formula for finding the area of triangle is as follows. Area of triangle ABC is equal to square root of S into S minus A into S minus B into S minus C, where S is equal to A plus B plus C upon 2. The practice set 15.4 is based on the Heroine's formula. We can solve in your notebooks. Okay, today we stop here. Next part of the area of we can see in the next time. Okay, today we stop here.